We're given the function f of x is x over 1 plus 7x squared. And we want to find a Taylor series expansion for it. We're going to start with a geometric series. We always start with what we know. We know the geometric series pretty well. It starts 1 over 1 minus x is the sum from n equals 0 to infinity of x to the n. So our goal every time is to start with the left function and see how close we can get to the original function we're asked about. Well, we have a 7x in our problem, so I'm going to substitute 1 over 1 minus negative 7x. I throw in the negative to make sure I get a plus. Since I'm substituting, it's going to replace the x in the right side. N equals 0 to infinity, negative 7x to the n, in parentheses. We don't like leaving series like this, so I'm going to multiply it out. Actually, I'm going to factor it out so that I get the x separate. So that's from n equals 0 to infinity, negative 1 to the n, because we like to see it's alternating, 7 to the n, x to the n. So we've now got the series 1 over 1 plus 7x if you simplify the left side. But we look back at our original series again and we say that has a squared in it. How can I get a squared in the bottom? We'll take a derivative. So in this step, I'm taking the derivative, d dx. The derivative of, we'll show it on the right side, the derivative with respect to x of 1 plus 7x to the negative 1 is negative 1 over 1 plus 7x squared times 7, because we have the chain rule. So negative 7 over. So now we've got negative 7 on top. On bottom we've got 1 plus 7x squared. So that's our left side, just taking the derivative. Since we do it to both sides of the equation, we take the derivative on the right. It's pretty easy, since the only term that has an x in it is the x. So the negative 1 to the n sticks around, the 7 to the n sticks around, and the derivative of x to the n is n times x to the n minus 1. So now we've taken the derivative. We look back at our new function on the left here. Does it look like our final version? Kind of. We're missing an x on top. So now I'm going to multiply by x to get negative 7x over 1 plus 7x squared. I'm only changing one thing at a time. And every time I look back at my original series to make sure nothing is changing and we're still heading toward that final goal. So since I'm multiplying by x, I should put an x in front of my series. That's what I'm multiplying by. Negative 1 to the n, 7 to the n, n, x to the n minus 1. Since this series has n's in it, I can bring my x inside. I couldn't bring this one outside. So I bring the x inside. That's now the series from n equals 0 to infinity of negative 1 to the n, 7 to the n, n times x to the n minus 1. So we have this new x term in the middle, which is what we multiplied the whole line by. That, when you simplify the right, simply becomes x to the n when you add the powers, because you're multiplying numbers with the same base. So we look at our left function. We say, how close are we to the final answer from the original top function? Well, we have the correct numerator except the negative 7, and the denominator matches. So I want to divide by negative 7, which is the same thing as multiplying by 1 over negative 7. So 1 over negative 7 times negative 7x over 1 plus 7x squared equals negative 1 over negative 7, series n equals 0 to infinity, and we bring our right side over. We've got negative 1 to the n, 7 to the n, n, x to the n. When I distribute this negative 1/7 through, it'll cancel with one of the negative 1's and one of the 7's. So they'll each have one fewer, so we can have n minus 1 many of them. So we get our left side simplified becomes x over 1 plus 7x squared equals the sum from n equals 0 to infinity, negative 1 to the n minus 1 7 to the n minus 1 n x to the n. And again, the negative 1 to the n minus 1 was simplifying. This came from negative 1 to the n over negative 1. This came from 7 to the n over 7. In both cases, you just subtract 1 from the top. So we have our final form as desired.